Hey everybody, welcome. This is Tom. We're gonna do another mechanics problem here. This is chapter 9, work, power, energy, all that wonderful stuff. And we're gonna do problem 4, which is on page 162. So this problem is dealing with a sports car. So let me go ahead and draw my sports car. I'm gonna make a blue sports car, and let's see, we'll have a nice little, there we go. That's my sports car there. Not the best sports car, but still pretty cool. And this sports car is going to be traveling along this road here. Whoops. Let me make a line instead. So it's going to be traveling along this road. And it's actually going to go, get that color back there. And it's going to travel 150 meters. And it's going to start at a velocity of 0, and it's going to end here. Okay, let me make these a bit bigger. It's going to end over here at 30 meters per second. And this vehicle it has a mass of 1.2 tons, which is equal to 1,200 kilograms. And so we've got all of the information we need. The question is asking us, the first part of the question actually is asking us the work done that for accelerating the car from 0 to 30. So we are not worried about wind resistance or friction or really anything like that at the moment. We're just worried about how much energy does it take to go from 0 to 30 accelerating at a constant, we'll say. Okay, so how much energy does that take? Well, because it's asking for work, or how much work does it take rather, because it's asking for work, your first inclination might be to say, well, I'll go ahead and break out my trusty work formula here, and I'll start plugging in information. I'll say, well, work is equal to force. I know the distance is 150. Okay, and then you say, well, I've got force, and force is equal to mass. I know the mass, but now I got to calculate the acceleration. And you could do all this, but in all honesty, there's a much easier way. And you just have to think about this problem in a different way. So you can't think about it, it's not just because it's a work problem, use the work formula. You need to understand what you're really measuring. And in this case, you're actually measuring the kinetic energy it takes to move the car from 0 to 30. So there's a certain amount of kinetic energy that this car will have by the time it gets to 30, and the velocity of 30. That is actually the amount of work it takes to move this car from 0 to 30, is just the kinetic energy. You don't have to use this formula here. You can actually just come over and just say, well, I've got my kinetic energy. Kinetic energy is going to be equal to 1/2, and the mass 1,200, and the velocity is 30 squared. Okay, and if you do this out, what you end up getting is 540,000 joules. Okay, so this here, much easier than doing this up here. Gives us the answer right away, and as long as we're dealing with something like this, we can use just kinetic. Now, I'm going to put this over here. I normally would have said subtract the kinetic energy, the initial kinetic energy, but since we're at 0, there is no initial kinetic energy. Now, if the car had started at this point at a velocity of 5, then I would have subtracted that initial kinetic energy from this 540,000 joules. Okay, so I hope you understand that part here. I'm going to go ahead and make a little line here because I am going to do the second part. Now, the second part of the problem says that if the driving force is in fact constant, what is the magnitude of the driving force? So what's the force that this car needs in order to get up to this speed? Well, if we look at the formulas that we got, we look at the information that we got, it's actually pretty easy to figure out the force. So while we use kinetic energy here to get the total amount of work it takes to move the car up to here, we can actually jump back to this and ask ourselves, what is the force? Because now we know the work and we know the distance is 150. So work, I'm just going to write the formula out here. So work is equal to 540,000. And the force is what we want to find, and distance is 150. So just divide both sides by 150, and you end up with force is equal to 3,600. Whoops. 3,600 newtons. Okay. So the first question asks us, how much work does it take to get from here to here? The second question asked us, how much force does it take to move the car here? And just using these two formulas, you can figure out the answers quite easily. Now, that's the trick of doing these problems, is really knowing what formula to use when. Like, what information do you have, and more importantly, what is the object doing? And drawing a picture helps a lot. Just getting to know exactly what's going on in the situation. Once you know what's going on in the situation, you can choose the correct formula, and you can choose or the combination of formulas in order to get your answer. Okay? All right. If you have any questions, just go ahead and leave them in the comments, and I'll get back to you as soon as I can. All right. Thanks for watching.